Hello everyone, this is a continuation of the runway designs. So in runways, here comes the geometric designs of the runway. The runway is an important airport element, so it is necessary to lay down uniform standard so as to serve guide for the designers. The items to be considered in the geometric design of a runway are as follows. First one is the length, second one is longitudinal and effective gradient, third one is rate of change of longitudinal gradient, fourth one is safety area, fifth one is side distance, sixth one is transverse gradient, and seventh one is the width. First one, length. The basic runway length will depend on the category in which the airport falls as per ICAO classification. The actual runway length is obtained by making adjustment for elevation, gradient and temperature with basic runway length, as we discussed in the previous video. Longitudinal and effective gradient. The longitudinal gradient of a runway increases the required runway length and also affect the aircraft performance in a number of ways. This is the table representing the longitudinal and effective gradient, in which the type of airport is mentioned and the maximum longitudinal gradient that can be provided and the maximum effective gradient. The next thing is the rate of change of longitudinal gradient. The sudden or abrupt change of longitudinal gradient is undesirable. It may restrict the height distance and may cause premature liftoff of the aircraft during the takeoff operation. The change in gradient should be made smooth by vertical curves, and as per the ICAO, the rate of change of gradient is limited to a maximum per 30-meter length of the vertical curve as follows. For A and B type, 0.1%. For C type, 0.2%, and for D type, 0.4%. The vertical curve are not generally required if the change in slope is not more than 0.4%. The distance between the two successive points of a grade intersection should not be less than the absolute numerical value of the change in slope multiplied by 30 meters for A and B types and 150 meters for C type and 50 meters for D and E type. And the table is representing the longitudinal grade changes, and in which first is the item maximum grade change such as A or B, as shown in the figure. That will be shown in the figure. This is the figure. A and B shown in the figure 4.8. For a small airport it will be of a 2%, and for a larger airport it will be of a 1.5%. The length of the vertical curve L1 or L2 for each 1% gradient change will be 90 meters and 300 meters. And the distance D between the two successive points of a grade intersection will be 75 into A plus B meters for a small airport, and for 300 into A plus B meters for large airport. And this is a longitudinal gradient. It will be cleared while doing an example or a question or problem related to it. So this is a problem that is related to it. The problem is the longitudinal profile of a runway is comprised of a rising gradient of 1.4% followed by a falling gradient of 0.5%, which is followed by a rising gradient of 0.5%. Determine the length of the vertical curve and the distance between them. So referring to the figure 4.8 and 4.3, in this case A is equal to, first one is rising gradient, that is equal to 1.4, and minus of minus 0.5, that is equal to 1.9%, and B is equal to Y minus Z, that is Y is equal to minus of 0.5 plus 0.5, that is equal to 1%, that is minus of 0.5 is equal to 1%. So since A is greater than 1.5%, the design is to be carried out for a small airport. This is because in the table you can see that if it is greater than 1.5%, it should be designed for a small airport. So L1 is equal to 90 into 1.9, that is equal to 175 meters, and L2 is equal to, that 90 is from small airport, L2 is equal to 90 into 1, that is equal to 90 meters, and D is equal to, as using the formula 75 into A plus B, that will become 75 into 1.9 plus 1, that is equal to 217.5 meters. The next thing is the safety area. The runway safety area is an area which is cleared, drained and graded. It includes the structural pavement shoulders on either side of runway and the additional width. The shoulders are generally unpaved. The length of the safety area should extend 60 meters beyond the runway on its either end. Thus the total length of the safety R will be equal to the length of the runway plus 120 meters. If the stopway is provided, the landing strips should be extended a distance of 60 meters beyond stopway. This is the figure indicating the safety area, from which you can see that the shoulders are unpaved and the runway safety area in between, in which 60 meters there will be an extended runway. The another is sight distance. No sight distance restrictions, as the longitudinal gradient for the runways are less, but there are chances for a collision of a aircraft at the point where two runways or a runway and a traffic way intersects. The recommendation of the ICAO with respect to sight distance are as follows. First one is, for A, B and C type of airport, any 2 points 3 meter above the surface of the runway should be mutually visible from a distance equal to the half the runway length. For D and E type of airport, there should be an unobstructed line of sight for any point 3 meter above runway to all other points 2 meter above runway within a distance of at least 1/2 the runway length. Then another thing is the transverse gradient. It is provided for a quick disposal of surface water. The accommodation of the water on the runway may produce hazardous situation for the aircraft using such runways. The ICAO recommends the maximum limit of transverse gradient as 1.5% for A, B and C type of airport, and 2% for D and E type of airports. It is suggested that the transverse gradient should not be less than 0.5% for satisfactory drainage. This is the diagram, the instrumental runway cross section. You can see that 1.5 is the maximum given, and for the runway transition gradient, and for shoulder you can see 5 to 2.5 is the value. Next thing is the width. The runway width varies from 45 meters to 18 meters depending upon the type of airport. The midway of the runway is governed by the following two main considerations, that are air traffic and outermost edge of aircraft. Air traffic. It is observed that the distribution of the air traffic is such that the central portion of the about 12 meter on either side of the center line of the runway is subjected to maximum loading, and it then goes on decreasing towards the edge. Thus, the center 24 meter width of runway pavement takes more concentrated air traffic load. The another thing is the outermost edge of the aircraft. The outermost part of machine of the largest aircraft likely to use the airport should not extend beyond the pavement. The shoulders are made of loose soil or stabilizing the soil. If the precaution is not taken, the loose materials from the shoulders is likely to get entry into the machine and damage the same. The distance between the outer engine of a large jet transport and the longitudinal axis of the aircraft is about 13.5 meters. So these are the geometry designs of the runways. Thank you.